Welcome to the European Space Agency ESA. Newton came up with 3 laws of motion, laws that describe how forces and objects relate to each other. Hi Pedro, Alexander. We can see that they're floating. They're pushing against each other and move apart. That's an ISS battery and it looks heavy. That means it has a lot of mass, right? Once again, they're pushing against each other, but Alexander moves less. What we see this time is that for every action, there is an equal and opposite reaction. Newton's third law of motion. Alexander pushes against Pedro, action. This causes Pedro to move, reaction. At the same time, Pedro pushes against Alexander, action, causing Alexander to move in the opposite direction, reaction. And they moved an equal distance, action equal opposite reaction. The battery's mass is about 80 kilograms, so now the force is the same, but the mass is different. Remember Newton's second law of motion. Action and reaction are caused by the same forces, but they're expressed through different mass. Therefore, Alexander moves less. Let's see what the schools are up to. Here we go. This is like Pedro and Alexander on board the station. We add another girl and they don't travel as far. The force of throwing the ball makes her move backwards. A collision, that's a force. But do you know why only the guy in front moved? The students are arranged in what we call a Newton's cradle. Skater collides with the first student, action. The first student tries to move away from the skater, reaction, but can't, because there is another student in the way. So, the force of the impact is passed through the next student and on to the end of the line. Then there's nothing stopping the last student, so off he goes. This is like the guys on the ice, only the last ball moves. And here the 2 balls are moving, but they don't seem to go as fast. This is because the same force is travelling through the cradle, but is expressed through twice the mass. As mass and acceleration are related, the 2 balls travel less than the single ball. The third law helps us in other areas too. Space vehicles use it to lift off. The air or gas is heated up and forced from the exhaust, action, and the reaction pushes the rocket up into space. Now you know about Newton's 3 laws of motion. Law 1 states that objects at rest or in motion stay that way unless a force acts on them. Law 2 says that the force is related to mass and acceleration. And Law 3 says that every action has an equal and opposite reaction. But why should we learn about Newton's 3 laws of motion? Well, it's all about science and research. Let's ask someone who has been into space.
Bonjour, je suis Claudie.
Hello, I'm Claudie Eniere. I've been lucky enough to lead a fascinating life. First, I was a doctor, a rheumatologist. Then I had a chance to start a career as a scientific researcher in the field of neuroscience. And all that with the idea of one day being able to take part in experiments in the field of space research. I was lucky enough to be recruited as an astronaut, first by the French Space Agency, later by the European Space Agency. A career as a scientist will bring you a lot of happiness, a lot of learning and development. Most of all, being a scientist means paving the way for the future. It means being curious, helping each other to build today's world, to build the world of tomorrow.
There are a lot more questions one can ask. Why is everything weightless on the ISS? How does being weightless affect the human body? But for now, goodbye.